Okay, what we're looking at here is a radio bar built in 1936 by a company in Los Angeles called Radiobar. It was fitted with a Philco Model 625 radio, and they only made these things for a few years. In about 38, Philco quit making that style of radio, so it wouldn't fit the bar. The bar is at the top. I'll open that up in a few minutes. You can see. It's about 4.5 feet tall. And we are going to do a restoration on this cabinet and the radio. Radios were all the rage in the U.S. back at that time. A television had been invented, but nobody really had one. By 1946, only 5% of U.S. households had a television. It was the radio that was used to keep up on the news from World War II, as well as other news and entertainment. So radio was the big deal. All right, we'll show you how this bar works. The top flips up. There's a mirror there. The mirror is in really good condition for as old as it is. It just needs to be cleaned up a bit. These sides fold out and exposing the full bar. You can see it's pretty wide. Those holes you see in the back are for lights. And somehow, I'm not quite sure yet, I haven't figured it out, that they came on when the top opened up. There's places there for liquor bottles. It looks like a hole down in there for ice, I guess. These are for maybe something to be chilled. I think a shaker went in one of them. And racks for other larger bottles on the left. You can see where it says Philco right there in the middle. And Radiobar Company of America right there. All right, we'll have a look at the radio. That speaker doesn't sound very good. As soon as I turned it on, that piece of paper came flying off of it. No, I'm just kidding. I didn't plug this thing in. That'd be the worst thing you could do to an old radio like this. Electromagnetic speaker, which was very common at that time. Okay, this is how I found it. I just pulled it out of the crate that it was sitting in. And you're looking at it for the first time, just as I am. There's the front. You can see that the dial's cracked in half. Like there's part of it laying over here, so you can see it sitting back there. There's just no way I can fix it. I don't even know what it's made of. This radio, and as did most of the larger ones at the time, used a transformer. This one has 6 tubes. You can see how warped that dial is, and it's just really not repairable. Here's a look at the back. You can see the antenna connections there. There's another antenna connection up on the top of the chassis. And you can see where the little light bulb is on the top that shines through the dial. All right, let's have a look at the inside. Other than this power cord that somebody soldered in there, this has never been touched. These are all the original components. I unplugged the rectifier tube and powered up the transformer and checked the voltages, 5 volts, 6.3, and 350 volts to the center tap on each side. That's good news, but there's a lot of work before we can actually power this thing up and test it. This is where I need to do a little bit of a disclaimer. I'm not a professional tech. I don't do this for a living. I'm a hobbyist. So my background is a commercial and industrial electrician, so I know how to work around high voltage. If you remember, I told you that we had 350 volts to the center tap on that transformer. Well, that's 700 volts total. If you're not familiar with working around high voltage, I do not recommend you get into one of these old radios or a guitar amplifier. If you want to learn more about it, my suggestion is to watch Uncle Doug, D-Lab Electronics, or if you really want to get into the weeds, Mr. Carlson's Lab. Those guys are pros, and they can explain how to work around this kind of voltage. Plus, they get way more involved in all the details of how all this stuff works. So that's what I recommend. So we start with the filter capacitors. There's 3 in this one. There's 2 at 8 microfarads in this can. Then there's another one in the next can over that's a 16. So I didn't have room for all that inside the chassis, so I opened up that can and I inserted a dual 16 microfarad capacitor on the inside and added a terminal to the top. So just saved a lot of room. The next job was to go through and check all of the resistors. Most of the time you can check those in circuit and you'll get a good reading. And so that's what I did. And I only found a few that were out of spec. That's the schematic. Sorry about the glare. And I had a parts list, and I also had a diagram of where the parts are located. It's great that you can still get your hands on these schematics and diagrams, and occasionally there's some misprints. The values of components in the schematic don't match the values that are actually in the parts list. There were only a couple of items that were misprinted that way. One was a capacitor, and so all I did was clip one end of the capacitor and then tested it and confirmed what it was supposed to be. All the capacitors were coming out anyway. We're going to check one of the resistors here. It's supposed to be a 1K, and I got 1.5, which that's too far out of spec. So I ordered all the parts, and a few days later they came in. So here I'm putting that filter capacitor back together, trying to get it to look as good as I can get it to look. As you see here, the vast majority of the capacitors in that chassis were old paper capacitors, waxed capacitors, and just had to go. There's no way you can trust them. And at this point, you see I've changed out most of them. You can see that's the 16 microfarad. I had to put that in the chassis. I didn't have any place else to put it. You can see where it was. It's that one where the post sticking out of it. So I left the can cap in there, but disconnected. There were a lot of connections to that 16. I didn't want to solder them all to the end of that capacitor, so I used a terminal strip. Just made it for a cleaner looking job. These other connections, you'll see the new wires coming out of there. They were replacing the other cloth wires that went out to the field coil and the output transformer. They were high voltage. I just didn't want that old cracked cloth wire hanging out of the chassis with 350 volts on it. So I replaced it with this with a plug in. It didn't have a plug before, so you had to haul the speaker around with the chassis. Some of these are going to be a kind of a pain in the ass to get to, but they have to be changed. Once I had all the necessary components replaced, it was time to test this puppy out. And first I went ahead and plugged it in, did a little preliminary testing on voltages in different parts of the chassis. You see, I had to do a workaround because I didn't have a speaker. So I clipped the wires coming out of the output transformer to that speaker, and I rerouted them to another speaker that I have. And it's drawing about 55 watts, about half an amp, and that's good. You see it kind of puts a little bit of glow in my current limiter. So nothing to be afraid of there. I'm using that lower 12-inch speaker for testing. So let's give this thing a whirl. See what we get. Aha, we've got noise. That's a great sign. That means this project is a go. Without that, this was going nowhere. It was going back in the crate. I rigged up a loop antenna that was also in the crate. I think it was for a different radio, though. I never did find the antenna that came with the radio bar. After moving some parts around and getting rid of some hum and some buzz, as you can tell, the radio started working really well. Picked up quite a few stations, and where I live, I'm in kind of a AM radio dead spot, so I'm really happy with how the receiver is working right now.
The blast occurred roughly 7 miles from...
Okay, well, I think for now we're going to leave the radio as it is. Seems to be working fine. We're going to move on to refinishing the console. So that will be in the next part, which I'm not sure when that will be posted, but thanks for watching.
They were in a village near Ukraine's border.